x-intercepts occur on tangent, and we talked about the vertical asymptotes. The x-intercepts occur at the pi's, the vertical asymptotes occur at the half pi's. So we were talking about the range, I guess. What's the range of this function? Negative infinity to positive infinity. And then, notice that they do not ask the domain. Somebody tell me why you think they don't ask the domain on this? It would be gap after gap after gap, because every time there's an asymptote, you would have to stop it and start it over again. It would be this, in union with this, in union with this, in union with this. So they just don't even ask. If they were to ask, you could write something like negative infinity to positive infinity with asymptotes at the half pi's, something like that, to imply that you understand that it stops every time there's a half pi. But they don't usually ask because it's a lot of different things. Okay, so then on question E, I think we were talking about this when the bell rang on Friday. Is this function considered periodic? And if so, what is the period? Every pi. Because when you're looking for whether something is periodic, you're looking for it to repeat the same behavior. And this one's clear and easy to see, especially if you look at this point right here. It starts at the origin. It has that crossing through point at the origin, and it crosses again at pi, and it would cross again at 2 pi, and it would cross again at 3 pi. So your period is pi. All right, so is tangent even, odd, or neither? And how do you know? What determines whether it's even, odd, or neither?
It's the same rotation, so odd?
It is odd. What makes it odd, Travis?
Rotational symmetry.
Rotational symmetry. It is the same upside down as it is right side up. So this one is odd. Alright, so now let's look at cotangent. So you can put cotangent in your calculator. If for some reason, my calculator has kind of I've used it for several other things. If for some reason your calculator is not the same as theirs, remember you can hit menu and zoom 4 and then 8, zoom trig. It's zoom 7 on the 84 if you have that. And then if I hit menu and 4 for window, and on my window settings, right now, if it's just the way my calculator is normally set, it's auto scaling on X. I want it to count by half pi's because that's what their picture is counted by. So I do pi divided by 2. And that, we'll put the hash marks on the half pi's, just like theirs is. There we go. Now, your calculator is going to write it in decimals, but 1.57 is pi divided by 2. So 3.14 divided by 2 is 1.57. Okay, so I can sketch what this picture looks like. Horrible drawing. What about the y-intercept? What's the y-intercept of cotangent? Not 1. What about the x-intercepts? Where do those occur?
At the pi over 2.
At the pi over 2's or the half pi's. What about the asymptotes this time?
At the pi's.
They're at the pi's. What about the range? Negative infinity to positive infinity. Is this periodic? And if so, what's the period? It is periodic, and the same behavior reoccurs every pi. Just because it crosses at the half pi's, this first place that it crosses is half pi. This is 3/2 pi, or 1.5 pi. So it's pi space between the two. Does that make sense? Or if you figured out how far apart the asymptotes are. The asymptote, there's an asymptote at 0, and the next asymptote's at pi, and then there's an asymptote at 2 pi. So the period is pi. Is this even, odd, or neither?
Wait, so-
Yeah, it's odd.
For parts A and B, how do you guys get that answer?
Where the y-intercept is?
Y and X intercepts.
Okay, we're just, are talking about number 6? Just look- just
5
look-
and 6, I mean both have in general. but
just
yeah,
look
just
at-
number 6.
Look at it, this is number 6, it's in my calculator. What is a y-intercept?
Whatever it costs.
Look at it,
It doesn't cost.
it doesn't.
Oh, okay.
And then-
oh, that's what you put down. Okay.
And then at the x-intercepts, it crosses here, 1.57, which is pi divided by 2. And then it crosses again here. Well, I know 6.28 is 2 pi. So it's between this line right here is pi, and this line is 2 pi.
So,
It's a half pi, it's a 1.5 pi.
Okay.
So,
cool.
okay, so then it asks for the similarities and the differences, or comparing them graphically. Similarities. Now, that's it, what'd you say? They do. They're going in opposite directions. One of them is rising, one of them is falling. And that's a good thing to make note of. Tangent is rising, and cotangent is falling, is a falling function. So that's a good thing to make note of. Similarities, honestly, even though they look very similar, they don't have many similarities, except the range. The range is the same, and the period is the same. But other than that, everything else is different. Yes.
What about like their symmetry?
Oh, good, that's the other thing. They both have odd symmetry. But other than that, because the asymptotes are at different place, the x-intercepts are at different place. One has a y-intercept, one doesn't. So even though they look very similar, they really only have a few similarities, and almost everything else is different. Things to look for when you are going to have to identify these graphs. I'll tell you what's coming up in the next week or so. We're going to be given word problems or problems, and it'll create a graph, and you're going to have to figure out which function works best. Well, one of the ways that you know you're going to use tangent versus cotangent. Tangent passes through the origin. Cotangent doesn't. Tangent is a rising function. Cotangent's a falling function. So these are the kind of things that you're going to look for in order to tell the difference between the two. Just like
is falling.
cotangent's falling. Because it starts at the top left and goes down to the right, so it's a falling function. Whereas tangent rises from the left to the right. Okay, so now secant tables and graphs. Keep all of these because these are like notes for you, because what is going to happen in the upcoming days is that we are going to start to take these are the parent functions that you're looking at of all of these, and we're going to do what we've done since the beginning of Algebra 2. We are going to transform all of these by shifting them, stretching them, compressing them. We're going to do all the things to the trig functions that we've done to the other parent functions that we've learned. All right, so here's secant table. It shows the unit circle over here on the right. Here's the table in the middle. There's a reminder here that secant is 1 over x and cosecant is 1 over y. Go ahead and fill in what secant of theta at this point would be, and then that's what you're going to graph. Now let me just warn you, find the asymptotes, graph those, but the image itself, you're not going to be able to get from the points that you get on this. So just plot the points and then I'll show you what the graph is supposed to look like. Because if you're just graphing, you're not going to get it from just these points.
Are you allowed to walk to the red one?
Oh yeah.
Did you walk?
I walked through the water stations. And then there were lots of people who walked up. There were some really, really bad hills. And lots of people walked up some of the bad hills.
the last stretch of the marathon
Yeah.
was a big hill.
It's a really, bad gradual
Like,
hill.
why would you do that?
Oh god, it's bad. It wasn't as bad as,
Oh, you want to run a marathon?
there's a really, really bad hill at mile 12. And in the half marathon, the really, really bad hill the two split off, and they have to climb a huge hill. It's bad.
Are they expensive to enter?
It's about 100. It depends. They always increase the price as it gets closer. So when I paid, which was back in November, it was 125. So it's not too bad. It's not too bad.
I won't pay to run.
Yeah. Gold.
You get a shirt and a medal and
Won't pay to run.
a bag. We got a bag.
Sounds like
That was bad.
I mean, you can say, like, you can play the marathon, which is like.
Less than 1% of the United States population does it. So.
Really?
I'm not part of that 1%.
I mean, you're not.
I am.
I don't even run
No,
half a
so-
mile,
You don't
so
mind. Probably just mom too, like, again, does.
I won't get there. I have a choice to run, but I don't.
Unless it's-
I was just talking about you. Okay, you can retest that test that you took.
Okay, so I got asymptotes at -pi/2, and then pi/2. Yes.
Negative 5/4. What did you say was 5/4?
It is. It's square root of 2. I was doing tangent for a minute there. If I messed these up. Okay, so I got these. Did I just do that before? Okay, so I got asymptotes at the half pies, -half pi, and then -3/2 pi, which wasn't on the table, but it repeats itself periodically. Okay, so one thing that you need to know about this particular graph is that while the x-axis is counting by, actually each little hash mark is a quarter pi, but these are half pies and then pi and then half pies. The y-axis is counting by regular old numbers, 1, 2, 3, 4, 5. So each little hash mark on the y-axis is a half. The reason you need to know that is because this time some of my y values don't come out even. So I get, for -pi, I get -1. So there's a dot there. And then for -3/4 pi, which would be this spot right here, I get -√2, which is about -1 and 1.4-ish. So, something.
It's like in between. Like,
I'm not a very good grapher. So it would be like there.
Yeah.
And then, let's see, I'm undefined, and then I get this, and that's okay, so now I'm going to put up what the actual graph looks like, because you would never, because we're not graphing enough points. I could give you 5 or 6 more points between those, and you would very obviously know what it is, but without the extra points, you're not going to know. So let me show you what it's supposed to look like.
It's supposed to be a sine wave. That's.
Alright, now this one is gonna have some extra stuff on it. Obviously, we put the asymptotes on there and they're not really part of the graph, but should look like that. The, obviously the asymptotes are dotted, and then the dotted thing that they put in here isn't really part of the graph. The only real parts of the graph are this. So we got these two dots, so we got that, and then I did these two, these three. And then there, we had these two, but we didn't get this one over here because they didn't put it on the table. But if you'll look, this dotted thing that they put in the middle, what is that?
It's a sign.
Huh? It's a wave, but which one?
Sign.
Cosine. Now why would it be cosine?
Oh, is it because it's not, it doesn't go through the center, it's shifted?
Because this is secant.
Oh, wait.
And secant and cosine
Sign.
are buddies. So it should be the cosine wave. Now the other thing is to identify it. Remember, it's the cone part of snow cone. It starts up and goes down. So this is cosine. And it's there because they want you to recognize that secant and cosine go together. So that cosine wave is there to show you. Remember, these are reciprocal functions. Not inverse functions, but reciprocal. It's the function flipped over. So think about that. If you look at the cosine function, if they took the cosine function and they flipped it open, they took the cosine wave and just flipped it, that's what they've done to make this particular graph. Okay, so with all that in mind, now see what you can do with cosecant down at the bottom. That's 3. Like that. Now this time, the wave in between is the sine wave. It starts at 0 and goes up from there because it's the snow cone, part of the snow cone. Other than that, it looks kind of the same. But when we get to the back and we talk about specific things, you'll realize just how different cosecant and secant actually are. So on the back, we're going to plug them into our calculator. There it is with no mess on the page, none of the asymptotes or any of that stuff. So x-intercept of secant. Secant does. I mean a y-intercept, I'm sorry. The y-intercept is 1. X-intercept, you're right, doesn't have it. Where are the asymptotes? Half pies. Is everybody okay? Does everybody know where we just got that? You can tell that it's not going to cross right here. And that's at 1.57, which is a half pi. And there's another one right there, which is at 3/2 pi. So it's at the half pi. Is everybody okay? All right, what about the range? Very good. Range is negative infinity to -1, bracket, in union with 1 to infinity. Is everybody good? All right, is it periodic, and if so, what is the period?
No.
Yes, and no.
What does it mean for something to be periodic?
So how did that happen?
So yes.
Okay, so does it happen over and over again?
No.
Yes.
It goes top and then bottom and then top. That's not the same thing.
Okay, but wait a minute.
Top on, top on.
Okay, but I'm glad you said that though, because you bring up a good point. But then it asks, but what is the period? So what Austin said is, but it goes top to bottom, and then top, that's not the same thing. Right, the period doesn't repeat from here to here. The period doesn't repeat until it goes from here to here. It has to complete a whole cycle, from top to bottom to top, like top to bottom to top. Every 2 pi. The period repeats every 2 pi. Whereas tangent and cotangent repeated every pi. All right. Even, odd, or neither?
Even.
Good. Why?
Y-axis with
Y-axis symmetry. Good. All right, so then they ask us G. How does the secant function, it's not asking us this time to compare secant with cosecant. Because realistically, secant and cosecant are not related. Secant is related to cosine. And so that's what they ask us to compare it to. How does secant compare to its reciprocal, cosine?
The asymptote is
The asymptote is what? What is the asymptote?
It's its reciprocal.
What is, oh, so on cosine, the asymptote, because cosine doesn't have any asymptotes, right?
Yeah.
So the asymptotes on secant are where? Where do we say the asymptotes were?
Every
Every half pi. Are they at every half pi or are they at every pi?
pi over 2.
The asymptotes are at pi over 2. What is that on cosine? It's the x-intercepts. So the asymptotes are the x-intercepts. Okay. What about the y-intercept? They're the same. The y-intercept of secant is the same as the y-intercept of cosine. What about the range? How are the ranges related?
The range of cosine is from -1 to 1, and that's the little part left out.
That's the one part left out of this. So on cosine, the range is -1 to 1. On this, the range is everything but -1 to 1. It's the piece that's left out. Okay, let's look at cosecant. What is the y-intercept? There's not one. What about x-intercepts? There isn't. Where are the vertical asymptotes?
Pies.
The pies. What is the range? Negative. We put in -1.
One including two.
Good. So it's the same, has the same range as secant. Is it periodic?
Yeah.
How often? Every 2 pi. Is it even, odd, or neither? It is. So it's odd. So how does it compare to sine? Let's take that last thing for example. This is odd. What about sine? Sine is odd also. So they have the same symmetry. By the way, we didn't mention it with cosine, but cosine and secant do. Cosine is even and so is secant. We've got the same relationship here between our ranges. The range of sine is -1 to 1. That's the one piece that's left out of this range. The place where our asymptotes are on this one happens to be the same places your x-intercepts are on sine. So all those relationships stay the same. Okay, so keep that one because we'll need to, once we start transforming them, you'll need to know what's what and which one you're looking at.